Alright, we've got 3 videos coming up from Chapter 25E. I think we've already had one as well. This is question 7, then I think we've got 10 and 11 to follow. But let's just go ahead and do this one. So we've got a box with 10 almonds, 2 of which are bitter and the remainder are normal almonds. Bitter doesn't sound very good at all. Brit randomly selects 3 almonds without replacement. Let X be the random variable for the number of almonds Brit selects. Number of bitter almonds. This is Britta and bitter. It's getting a bit tricky. Find the probability distribution for X. Well, the first thing we can do, we might do a little table for this one because it'll look a little bit nicer for you. So what are the possible values? X could be, she could have 0, or 1, or 2 of her almonds being bitter. And now we just have to find the probability that X equals little x. Now, it went and did the same thing did it to me last time and made that a capital X when I didn't want one. So, how would I end up with 0 bitter almonds? Well, that would mean, so if I'm doing part A here, the probability of 0, or probability that X equals 0, or 0 bitter, however you want to write it, is I'd have to choose all 8 of my almonds, all 3 of my almonds from the 8 that are not bitter. Now the total number of ways I could come up with a set of 3 almonds would be just choosing 3 out of the 10. So if I do 8C3 divided by 10C3, that will give you the answer. I could also end up with 1 bitter almond. If this is going to be the case, from the 2 bitter almonds, I'm choosing 1 of them, or Brit is, and then from the 8 normal ones, she is going to choose 2. That's the 3 in total that have been chosen, and we divide that by 10C3. And finally, if we wanted both bitter almonds, from the 2 we'd have to choose 2, that's easy enough to figure out, and then from the 8 we'd have to choose 1, so that's going to be 8 divided by 10C3. Now I'm going to cheat here because I can't be bothered doing the calculations on screen. I'll write them down and I'll be back before you even know it. And you can see when you work them out there, we've got 7 over 15, 7 over 15, and 1 over 15 being the probabilities. So that's my probability distribution. When I get down to B here, so yeah, we can go back and write those in if you want. 7 over 15, this one's 7 over 15, and this one's 1 over 15. If you can't do those calculations, let me know and I'll show you how, but really 8C3, you're using a calculator to do that, so you should be right. Find the mean of X. So for B part 1, remember mean is just the expected value, so expected value of X, or the mean value of X, it's going to be 0 multiplied by 7 over 15, which is of course going to be 0, plus 1 multiplied by 7 over 15, plus 2 multiplied by 1 over 15. And if you go ahead and calculate that, you've got 7 fifteenths plus 2 fifteenths, 9 fifteenths, or 3 fifths. That's that one. Standard deviation, again, it's a yucky calculation. You can do that on your calculators. You can go through it the long way if you want. I'm not going to do that today. Alright, see you in the next one, 25E, question 11, I think. See you then.